nice things. I'm John Diana. I'm one of the research assistants, I would say. I'm the coordinator at Western States for research. I just help, organize the researchers. We have some fantastic people that do some studies on various aspects of ultra running, from performance-related things to metabolic things to injury-related things. And at one point, the research for ultra running was, it's not that much out there. But something like 65% of the studies that have been done had come through Western States. So it's been funded by by our board every year. Our board has a very high interest in the subjects, and so today I have Emily Krause, who's been running our research for about the last 3 years. We've a project that is on bone stress injuries, and also Megan Roche, who's been helping. She'll talk a little bit about performance in ultra running and some other aspects. She's a world-renowned coach as well, so she can give some advice there. And so anyway, with no further ado, it's Emily Krause. Thanks.
Thank you, Dr. Diana. So I feel like we first met a few years ago when we were starting to get this idea as far as an initial study at Western States, and I wasn't aware of what the Western States Research Foundation, what the capabilities were. As a researcher who enjoys doing these types of studies, it takes a lot to get involved with a race and get the funding, get everything coordinated. And without the Research Foundation, Western States Research Foundation, without John, we wouldn't be here. We wouldn't be on our 3rd year of doing this study. So I wanted to be able to share some of our research, because that was always a question that a lot of athletes had, is, will we be able to see the results of some of the research that you're doing? And I'm like, yes, at the time of the research. But unfortunately, sometimes it takes a year or two to get all of that data analyzed and all of those publications in. So thank you all for your patience. But today I'm going to present on genetic environmental predictors of low bone mineral density and bone stress injury in ultramarathon runners. A big shout out to some of the research team, Megan Roche. I think this might be her leaping over some large little crevasse there. And Tracy Haig, she's actually covering, doing some consents right now for part of our study, so she's not here, but she said that she'd catch the recording later. Dr. Olson at Stanford, Kira Skaggs, one of our summer interns, Kristen Sonani, an amazing statistician, and Dr. Michael Fredrickson, my mentor. So a little bit about me. I was born and raised in the Midwest, Nebraska, born University of Nebraska-Lincoln, studied nutrition science, which came in really handy red, and studied physical medicine and rehabilitation, or physiatry, and then stayed on at a sports medicine fellowship, and now I still work at Stanford. So I'm a proud aunt, lots of nieces and nephews. I do like to run 2 years ago, and that was my one and only, but it was memorable, and I still have some scars. All right, so I wanted to dive into a little bit of background. So bone stress injuries, also known as stress reactions, stress fractures, represent the inability of a bone to withstand stress from repetitive sub-maximal loading. So in an ultramarathon, you do a lot of repetitive sub-maximal loading. And so as you can see, distance runners are at the highest risk based on numerous studies. The yearly incidence of bone stress injury among track and field runners is around 21%, and the very few looking at factors for bone health, low energy availability, which I'll go into definitions in a little bit, kind of be categorized in a couple of different ways, maybe with an increase in overall training. I see this a lot in the transitions from middle school to high school, JV to varsity, varsity to college, standing as far as the overall importance of nutrition, but sometimes some of those habits that were done earlier in the life help manage that athlete in that current setting. And the hardest competitive edge by continuing to restrict. And that's when, unfortunately, the effects of low energy availability, and I promise not to lecture today and get too deep into the science weeds, but I think it's important to know of certain hormones kind of down the cascade. So that can be suppression of different sex hormones, suppression of different thyroid hormones, which then leads to adrenal glands, which leads to elevations and overall stress. And then that can also, a triad was coined in the 1980s, and it consists of 3 interrelated components: low energy availability with or without an eating disorder, irregular population, it can just be low bone mineral density based on that age, and there are different definitions based on athletes engaging in weight-bearing sports. So this definition was expanded to female athletes, maleathletetriad.org to get more information about some of these definitions. An expansion of a term of the triad called relative energy deficiency in sport. And that's called RED-S for short. So you can see the triad nicely here, but you can also see these other physiological and performance consequences from relative immunological consequences, GI effects, cardiovascular effects, and those can be a little bit harder to diagnose until a little later in that presentation. So we use this cumulative risk assessment tool a lot in our clinic. It combines a lot of these triad risk factors and helps us stratify an athlete at low, moderate, and high risk. And this is really important because we're using this tool to help stratify athletes into low, moderate, and high risk in our research study. So recently that there's been more research finding a genetic link with certain components that correlate to low bone mineral density. This started in the UK with a large biobank of single nucleotide polymorphisms, also called SNPs, and they found that they were predictors of heel bone mineral density. Dr. Stuart Kim, back in 2018, combined these genetic algorithms with height, weight, age, and sex, and called that the BMD osteoporosis genetic risk score, or the BOG. He found that the BOG did correlate to low bone mineral density, but it has not really been studied in an athlete population, specifically the ultramarathon population. So the purpose of our study was to explore these risk factors for low bone mineral density and prior bone stress injury in male and female ultramarathon runners. So our methods, this is our year 3. Our first year, we only did DEXA bone mineral density scans, and so that we measured bone mineral density of the lumbar spine, femoral neck, and total hip. We had each athlete recruited fill out a pre-race online survey, which asked questions about disordered eating, bone stress injury history, or stress fracture, stress reaction history, irregular periods in females, as well as training volume. And then at the race site, we got genetic testing, and then we also got lab draws the last year and then this year. And we studied estradiol, total and free testosterone, and our secondary analysis, we also looked at the results that I'm going to be presenting are the descriptive variables from the last 2 years. This was recently, but you can see the breakdown. 40 women participated and 83 men, which is pretty similar as far as the ratio. Country breakdown as well as running level. You can see the women, there are a little bit few more in that kind of higher elite professional category. And then you can also see as far as the mileage per week, a little bit higher in women, as well as the running time and years racing. Half of women were trying to lose weight for performance, and 46% of men were trying to lose weight for or anything that would. We really start to a little bit more detail in another slide on that. So based on the questionnaires, self-reported questionnaire, we found over 2/3 of females were defined as moderate or high risk of low energy availability, and as moderate or high risk based on this questionnaire. History of bone stress injury, which is higher than the averages that were found in some prior ultramarathon studies, and then around 30% of males had a stress fracture history. Sorry, math, 20% of males. And then as far as bone mineral density history, or bone mineral density scans, which I should also mention, if you see those body spec vans, there are 2 DEXA scanning machines there, and so they are getting bone mineral density scans on site, which is pretty incredible that we're able to accomplish that. So thank you from the foundation again for helping coordinate that. So only 16.7% of women were categorized as moderate or high risk of low bone mineral density. However, you can see quite a bit higher number, almost 35% of males were categorized as moderate or high risk of low bone mineral density. And then looking at irregular periods, 30% of females were moderate or high risk of delayed menarche. So even though that the average was in that 13 range, there were still 30% who know that. And I even think from a coaching perspective, understanding that as far as when you prescribe training, you might need to be modifying that training postmenopausal women who are also having irregular periods, and then women on some form of hormonal contraception. The women are on your left, and their average ferritin level was 30.8. There's a lot of controversy as far as whether that's defined as normal or abnormal. In my world, and an athlete that's doing it, it's very different. And then as far as vitamin D levels, 31.3. An athlete comes into me with vitamin D levels. Statistical analysis was that genetic risk score, that BOG, was significantly these similar correlations in the female population. Overall risk that does not, even despite that genetic risk, it doesn't affect the overall bone mineral density, both positively and negatively. So with this specific population, we are underpowered in the female population, hence why we're getting more research today and tomorrow. And testosterone and free testosterone were all significantly correlated with higher bone mineral density. So the higher the estrogen level, the higher the testosterone level, the higher the bone mineral density. So it kind of goes back to those sex hormones really coming into importance as a possible indicator of overall bone health. So some of the conclusions, that bone mineral density genetic risk score was hormones were correlated with higher bone minerals, and we did not find the same correlation in males. Self-report. So this is something that they're reporting anonymously to us, and her coaching and performance among females was pretty similar to the general population. Ultramarathon runners to this degree. Limitations, small sample size, especially in the females. These are self-reported data, so some of these, there could be some inaccuracies as far as especially long-standing stress fracture history. And it's a bit more of a heterogeneous population compared to other running groups studied, which is the beauty of ultramarathon running, and I think one of the reasons why I really enjoy working with this population. So I want to give another big thank you for the Western States Research Foundation. Also, all of the participants who volunteered for this study. If it weren't for you, we would not be able to find this novel information and not be able to continue to do this work. Our statistician, Krause Sanani, is a boss, and I just am so impressed with what she can do and really make sure that we're presenting this information as accurately as possible. And then our stellar research team, Dr. Roche, Rory, who's out there right now collecting data with Tracy, or Dr. Haig, and of course Dr. Diana for really always being that great liaison with the Western States board. And then our partnering vendors, Axgen with the sports genetics analysis. We could maybe save the question, swing by our consent location and ask us questions, and we can share more with.
Thank you. Thank you so much. And thank you to everyone out here. We made it. Like, think about during COVID how, I was looking at this race during February and March and being like 6 feet apart, and just like how awesome and amazing that is, and how much a regional route. 5% of people knew what epidemiology was before the pandemic. Most part, people do know what it is. Right there is my co-coach David. Years ago, this is probably our favorite day of the year, but I would also say, mountain runner. I'm constantly kind of terrified I'm going to break my neck. So a co-host of the Some Work I'll Play podcast with David. Good bit of science. Actually, all of these tests, and there may be a little bit of rocks. So this right here, I'm going to play this video. She was hammering, so she has 40 miles, something great. And this is her just like navigating these next 40 miles, just unleashing. It's because I think running performance is incredibly complicated. So I think going into running performance is the idea of, she has all of those. And she put type of energy is incredibly challenging to study in scientific articles and scientific studies, because it's really combining so much together of a life force that it's really, really hard to see in research. So for Walmsley's fitness this year, whether I was talking about with energy availability and actually within day energy deficit. And then just a quick few slides on the science of self-belief, which will hopefully provide some humor and fun. Study. This is a 2019 study, and how those runs were associated with top running performance, period of months and weeks. And it's fantastic, and developing running. And then they had the athletes self-report what they were doing. And we really need a push to have more female athletes being represented in research. So the results from this difficult, I know I'm not fantastic with my own training log. My coach hubby has to poke me probably once a week and say, Megan, update your training log. What are you doing? And so those are the disclaimers before we dive into this. So what they found was that the volume of easy runs actually had the highest correlation with performance, from 0.72 at 3 years to 0.6 at 7 years, which is actually a pretty high correlation for those in science. And so I think this really gets at the point that consistent easy running drives a lot of recovery and adaptation throughout this process. And it's really about the recruitment of these slow twitch type 1 muscle fibers, which can happen. You can essentially alter those recruitment patterns over these long periods of time of doing easy running. Also layered into that too, I think kind of extending extending it beyond this article, cross-training is fantastic for building the aerobic adaptations, for thinking about these slow twitch muscle fibers, and something great that you can add in too, especially if you have injuries. Point number 2 is that tempo runs actually became more. This is important because up-tempo runs are this, you don't have to go out there and like crank out these laps on the track. You can kind of go out and do tempo runs in semi like unstructured ways, but intervals actually had lowest correlation with performance. Like how efficiencies over long periods of time can sometimes be more tempted to race these and make them fast. And if you're doing that consistently, it's actually a challenge because it's really putting a lot of stress on the body. I see a lot of blood work, and sometimes if an athlete is pushing too hard, that's when cortisol becomes a big issue, it's stress hormone. The fourth point is that short intervals had a moderate correlation. Short intervals, I love short intervals. So talk about like power hill strides, 1 minute intervals, 2 minute intervals, 3 minute intervals going forward. Hard work, getting up, like showing up when it's not easy, putting in the work. Like I think. So this point here is not just like gazing longingly, so I'll kind of skip going into the details on this, but just so within day energy and it's true, we will all natural states, even if you control for low energy availability over a 24-hour period, quantity of food intake that you're having throughout the day. What they've shown in research, and then also similar findings with male athletes and testosterone. So we have the hypothalamic, that's very hard to say, the hypothalamic pituitary gland, and that they impact a bunch of different menstrual health to stress response, mental health, including depression, adaptation to trauma. Athletes come to us with a stress fracture as their first sign. Some athletes come to us and are just simply fatigued and are like, why am I not progressing? And it's fascinating to see how, just like some quick hitters on thinking about avoiding low energy availability and within day energy deficits. So one, I think there's a lot of value in support teams. So I think developing a team of a nutritionist, a psychologist that you have with nutrition can be really helpful in this process. Focus on fun, fulfilling foods and calorie-containing beverages. So I think nutrition should ideally be up at dinner. It's like anxiety-producing, and that's okay, and that's totally okay too. But I think like as far as nutrition research goes, we actually saw I think it's really important to think about which studies you're looking at as a female athlete, and to recognize that like female athletes to power performances, to all of this, is that injuries are going to be inevitable. If you shoot your shot, if you put yourself out there during reconstruction surgery, stepped in a hole in an ankle a few weeks ago, and you put yourself out there enough, and it's going to happen. Density ranges from 40 to 60%. So Achilles tendon, and I think beginning to explode the avoidable. So 2 to 3 days off, way better than 2 to 3 weeks off. Much, much better than 2 to 3 months off. And athletes often, when they take rest days, as I said before, injuries and coming back too fast. So you can work with throughout the duration of kind of like a minimum protein intake are fantastic. Get an understanding for what the body is doing, what it's taking a week completely off before getting back into cross training is, oh my gosh, like you have to cross train. I personally love biking. What about that process is actually really helpful for power development. Doing those at higher RPMs, so somewhere around like 90 to 100, which is a little development that you use when you run. In terms of strength and mobility work, Jay Johnson has a total mess, but now thousands. I was 6 and I sunk for 2 or 3 days. I get kind of imploding. It can help with biomechanics, help with neural running. This llama is on here because every time I return to running, I return back and I tell David, I'm like, I feel like some kind of lumbering farm animal. Like it feels terrible. My legs feel heavy. I feel like I've never better. So if you too feel like a lumbering zoo animal of choice, it's totally okay. It will get better. And then just to wrap up, I think I'm super excited. It will get better. And then just to wrap up, I think I'm super excited about Western States, about being here, about crew members, about pacing, about research. The next few slides are about the rigorous science of self-belief. So this first point, you are enough. This is something that David and I emphasize continuously with our athletes, is that whatever happens tomorrow, in the next race, in the next race, in the next race, you are enough, and you are enough at the end of the day. Point number 2, you are perfect as you are, also building on you are enough. I think it's looking into the mirror and saying this, and it is not a test, because that's what life's about. And
said, Emily, how'd I look in the, all these. That's what I recommend, or amount of running you can do to get a 100-mile finish.
Study this population. It's like how to predispose a timing of training. We haven't done any. There is a way to kind of stay with seriously studying this, is to see, especially in the bigger population, link between bone mineral density and full. for additional analyses. We do ask some questions on overall strength training and the number of days per week of strength training. Megan, I think per week, however.
Yeah, so and the genetic stuff is fairly new. As we actually have done a place in New York, a lot of money, that they'll which was see why, the differences there, or how it affects variables. As far as, in fact, Marty Hoffman, a guy who did a lot of the work here, had an interesting paper that read down the list. It was and in the end of the day, just if you look at those different, they didn't do, they probably did appropriate things for your race. Rely only on.
Interesting. I think as the race gets longer, of being able to accelerate is this idea of central fatigue resistance, endure.
Enjoyed it. Thank. I learned that as I was going along. Appreciate it.
I know, I got a text message.
What do you mean when you talk about intervals on bikes?
Yes. Could be very similar to running. So going out there and doing some anywhere from like 10 by 30 seconds, pushing the body harder to 3 by 10 minutes.
Question for you.
Yeah, and then everything.
So basically the same kind of thing. When you like one of the things I used to do with track when I was in shape was sort of guess how.
Yes.
Do 1 week and then 3 weeks slow.
Yes, it's the same exact thing. It's a little, it feels very different because you're on a bike, but it's about, putting out, getting the heart rate higher, working harder for 30 seconds, and then recovering more for a minute, so the heart rate is lower. And that delta between the heart rate is what the body really adapts and recovers, the response to the I know it seems conceptually weird to anyone on a bike, but it actually is great.
At least actually on a bike rather than on a train.
Yeah, like actually outside. It's actually much more pleasant outside. Yeah.
It's almost been cost of you. Why do something inside when you
Because you could be out there.
places
It's
like
beautiful.
this?
I know. I rented actually a bike here, but it's a cruiser bike, and I was out there this morning just like hammering away at like 5 a.m. Thank you for coming. Are you crewing, racing?
No. I mean, yes. I always like kind of something racing, particularly the medical stuff, because I did pretty well at endurance running. A lot of it, asking huge numbers of questions, seeing what works. Training yourself not to sweat salt, still needing to take salt, limited to the right amount.
I just sort of hover above it.
I did everything I could think of, and it paid off.
That's awesome. It must be fun to come back. Oh.
I would say if I compare myself to somebody who's getting similar performance as I was getting, he would be better running uphill and I would be better. Darwin was also earned ideas. But it was fun.